Good day, everybody, and once again we're back together. Thank you so much for joining us. And today we are looking at solving trig equations by finding the general solution. I've really been looking forward, to these particular sections. Trig is quite a lot of work, and of course we are taking it one step at a time. I hope that you've been enjoying our lessons, and for those of you who are new to the channel, welcome, and please just make sure that you hit that subscribe button. Just make sure that you're part of the family, okay? And we are a growing family, okay? Thank you so much for those of you who've been part and who are continuing to enjoy our lessons. All right. If you need assistance with mathematics or physical science, you're more than welcome to, get in touch with us, and our email address is info@mlungisinkosi.co.za. All right, now what we're going to do is just look at a couple of rules when it comes to sine, cos, and tan. And I'm sorry that I'm going to have to relate this, but I haven't really covered the graphs with you, but I'll kind of be toggling between the two so that you can be able to follow on in what I'm doing. Right, so when we are finding the general solution, so first of all, we're looking at, let's say, for argument's sake, for the sine graph, okay? So what we must always do is try to isolate our equation such that we end up with one trig ratio, okay? So say for argument's sake, you end up with sine of a particular angle, okay, is equal to, let's just say A, okay? Now, what we're going to do is work out the value for A. Now, please, I want you to listen to me carefully, okay? So then we're going to say X. We're solving for the solution, and we say, well, that's going to be the arc sine, all right? That's not the inverse of sine, but this is the arc sine of A, all right? So we are finding the angle, all right? So when we find that angle, we call that a reference angle. So in this case, it means that we're going to have a reference angle. Let's say whatever that reference angle is, let's call it beta, okay? Now for sine, please listen carefully. So the sine graph always repeats after every 360-degree cycle, okay? Right, so what does that mean? If I find a solution, that may be a solution, that solution would be the same after 360. It would be the solution after every 360-degree, cycle, right? That goes for the cos graph as well. But I want you to note, if I say this is the solution, well, look at that. It would also be the solution there, where, it's 180 minus that reference angle. Now, please, I want you to listen carefully. So when I take the reference angle for sine, it's always going to be X is equal to, whatever angle that you find. But in this case, we always say plus K 360, okay? So meaning that K is an element of integers, okay? So A is an element, K rather is an element of integers. Or another value would be X is equal to, now please note, it's always going to be 180 minus the reference angle, okay? But please remember as well that you're going to say plus K 360, and your K would be an element of integers. Please, your general solution does not make sense if you don't add the fact that K is an element of integers, okay? Right. So that is how we're always going to look at the reference angle for sine. All right, so I want us to quickly go to the one for cos, all right, because we're going to apply this in quite a bit. All right, so suppose that we've got the cos of y being equal to some value. Okay, let's say that is equal to a value b. So again, what are we going to do? We always try to isolate until we get to the point where we've got one trig ratio. And what are we going to do? So our y, in this case, we're looking for the angle, all right, is going to be the arc cos of b, all right? So remember, that's not the inverse, okay? So that's the arc cos, so you're looking for the angle. So in this case, it means that y would be equal to, let's just say for argument's sake, that angle is alpha, okay? So y is equal to angle alpha. Let's say alpha is 30 degrees or whatever the case may be. Right, now, here's the thing about the cos graph. The cos graph actually looks something like this, all right? So the cos graph reflects itself around the y-axis, okay? So it's a reflection of itself. So it means that if you were to fold the cos graph around the y-axis, the two graphs would sit exactly on top of each other. So what happens with the cos graph? Please, I want you to listen carefully. So that means that when I find a general solution for the cos graph, I am not just going to say it's that solution, but it's actually now going to be plus or minus that solution, okay? Why? Because it can either be the solution on this side, on the left-hand side, on the positive or on the negative. It's got the same value on the positive and the negative side, okay? So in this case, it's going to be plus or minus my reference angle, but I also need to remember to say plus k 360. Sorry for that little mess there. I'm trying to erase actually. Okay, so plus k 360, okay, where k is an element of integers, okay? So please remember, when we're talking about integers, we're talking about, whole numbers, 0, 1, 2, 3, and so on and so forth. Okay, right. So those are going to be our integers. So in that case, remember, when I take the reference angle for cos, it will always be plus or minus the angle, and it will be plus k 360. All right. And finally, I want us to take one for 10. So suppose that we say the tan of the angle, okay, so tan of z. Okay, now let me not use z, because then you'll think when I use that sign for integers. Okay, so let's say tan of m, okay, is equal to some angle, it's equal to some value. Okay, let's say n. Right, so in this case, how do I find the angle m? Right, so m would be the arctan of n. Okay, so whatever the value is there. Right, so m would be, let's just say for some reason, m is equal to some angle. Okay, all right, so we've used alpha, beta, let's say it's gamma. Okay, so m is equal to that angle there, gamma, right? But now for 10, you don't have plus or minus, because for the 10 graph, it looks, let me just show you quickly. The 10 graph is one very strange graph. So what it does is that it's got an asymptote there, all right? So it looks something like this. Got an asymptote there, you've got another asymptote there. Okay, so this would be at 90. Okay, and then so what the 10 graph would look like, so this is 180. Okay, and you've got another asymptote at 270, and so on and so forth. Now what you'll notice is that the 10 graph repeats itself at every 180 degree cycle. Please, if you don't understand this for now, please don't worry too much about it. We are still going to tackle graphs, okay, trigonometric graphs, so don't worry too much about it. So what I know is that when I find the solution for x, for 10, I always need to say, right, we're not going to have plus or minus or anything else, but I am just simply going to say plus k, now not 360 this time, plus k 180, and again k is an element of integers. Okay, so those are the things that we always need to keep in mind when we are finding our solutions. Now I'm going to actually break this lesson down into two. I'm not going to finish everything today because there is quite a lot on this section, all right, because there are some rules that I'm going to take you through as I continue. What I want us to do is to jump into just a couple of examples, and then of course we'll continue in our next video. Okay, right, let's go into our first example. All right, now let's have a look at a couple of examples, and we're going to leave it here for today. And of course, we're going to make sure that you get the best of how to solve these, and obviously continue on the other lessons. Right, so they say determine the general solution of the following equations, okay, and you must round off to 2 decimal places. Of course, the examiner is always going to tell you or give you instructions of how you should round off. Right, so let's start with the first one. We've got 2 sine of 3x is equal to 0.4. So the first thing that we're going to do, always isolate your trig ratio. So in this case, I've got the sine, 2 sine of 3x, which is equals to 0.4. So I want to just isolate my trig ratio. So in this case, I've got sine of 3x. So I'm going to divide both sides by 2. And in this case, I will have sine of 3x is equal to 0.2. Now, please, I want you to note, in this case, I now have sine of 3x equal to 0.2, and I've got sine as positive. Now, obviously, what does that tell me? Sine is positive in my first quadrant as well as my second quadrant. So now I'm going to find the solution. 3x is equal to the arcsine of 0.2. Okay, so let's find that quickly. So that's going to be 0.2, and I have 11.54. So it means that 3x would be 11.54 if I round it off. Okay, but now please keep in mind, because that would be in the first quadrant. Okay, so this would be in the first quadrant, but it also is in the second quadrant. Now, if it's in the second quadrant, we always say 180 minus that angle. So in this case, so that means another solution. So this is plus k 360, where k is an element of integers, but also or 3x is equal to, that's the next solution, it's in the second quadrant, it's 180 minus 11.54 plus k 360, okay, where k is an element of integers. Okay, right, now obviously let's try and solve for the two. Unfortunately, I couldn't put them side by side next to each other, okay, but I hope that you can understand that. So it means that 3x, now if I divide that by 3, that would mean x, by the way. So I would divide obviously each side by 3. Okay, so 3x is 11.54. Okay, let's deal with this one first. 11.54 plus k 360. Okay, and you'll see I always insist on saying k is an element of integers. So divide by 3 on both sides. Okay, and remember, everything should be divided by 3. So x is equal to 3.84 5. Okay, so I try to take the answer as it was. Plus, now in this case, not K360, but this is going to be 360, all right, divided by 3. And in this case, that's going to be 120. So this is plus K120. But remember, this is where K is an element of integers. And remember, our second solution was this one. Let me get that 180 minus 11.54. And in this case, I get 168. Or, so this is our second answer. Or x is equal to 168. Actually 3x, is equals to 168.46. Okay, plus K360. And I'll say where K is an element of integers. So divide that by 3. Okay, so if I divide that by 3, I get 56.15. Okay, so divide by 3 also on this side. So x would be equal to 56.15. Okay, 0.15 plus K120, and K is an element of integers. So that is how we would solve that. I wish it was possible to have to put them side by side, but those are the two general solutions that we would have for sine. Okay, right, so that is how you're going to tackle it all the time. Okay, so I want us to quickly go to the next one. All right, so the next one was 1 over 3 cos of x is equals to minus 0.2. So what we do, remember we said we always need to isolate our trig ratio. So what I'm going to do is just multiply by the inverse of on both sides. So I'm going to multiply by 3 over 1. But what I do on the left, I do on the right. So I multiply by the inverse, so that 3 will cancel that 3. And at the end of the day, I'll just be left with cos of x is equal to negative 0.6. Now, I want you to keep in mind, when we think about our Cartesian plane again, where is cos negative? So cos, remember, okay, so first of all, I know it's positive in the first and the fourth quadrant. So meaning in this case, it would be negative in the second and in the third quadrant. Okay, so that's going to be important when we find our answer. We're going to find the reference angle first. So let's find the value of x. So now x would be the arc cos, once again, of negative 0.6. Okay. All right, let's find that answer quickly. So arc cos of negative 0.6. Okay, and I find my answer to be 126.87. All right, so remember we said that's correct to 2 decimal places. So that's our reference angle. But remember, we must always say plus K360, okay? And we know that K should be an element of integers. In fact, you only need to say that once, okay? So in this case, remember what we said, for the cos, okay? So we can either say plus or minus. All right, so we said that's going to be plus and minus. So we've got 2 solutions. Remember, we said in the third and the fourth quadrant. So means that x is going to be right. So in the second quadrant, it is going to be that value 126.87 plus K360, or in this case, just look at this. The one in the third quadrant, what we can do is just add 360 to that. the one in the third quadrant. So we can say that this would be x is 360 minus that angle there, which is 126.87 plus k 360, and what we get there is 233.13 plus k 360. That's our next angle in the third in the third quadrant. Now, just another way, I just wanted to show this so for future reference. What you could have also done here is just get a reference angle in the first quadrant. Now, please, I want you to listen carefully. So we ended up with cos of x is minus 0.6. Okay, so we ended up with cos of x is equal to minus 0.6. But what you can do is just omit the minus 0.6 so that it gives you a reference angle, and I'll explain why. So x would be equal to the arc cos of 0.6. So I'm omitting the negative. Okay, so what you would have found there would be 0.6, and what you would have found there is 53.13 degrees. Now, please, I want you to listen carefully. So in this case, that means that would be my reference angle in the first quadrant, right? But I know both my solutions are in the second as well as in the third quadrant. So for the solution in the second quadrant, I'm going to say, well, it's going to be 180 minus my reference angle. And what's my reference angle? 53.13, okay? Of course, plus k 360, right? Because we have to write all of this, it just makes this thing too long that I can't fit both of them, okay? Or for my angle in the third quadrant, remember in the third quadrant, that's 180 plus, okay? So remember in the third quadrant, if I have to draw my Cartesian plane, so that's 180 here. Second quadrant, it's 180 minus, but third quadrant would be 180 plus. So that would be 180 plus 53, sorry about that, 53.13, okay, of course, plus k 360, okay, plus k 360, all right. Sorry for that mess there. My rubber sometimes, my eraser rather, does not work. Okay, so this is plus k 360. Okay, and so your reference angle there, or rather your solution would be 180 plus 53.13. And so what I get is that value that I got there, which is 233.13 plus k 360, and those are my two solutions for the sine. So I actually didn't give the one for this one. 180 minus 53.13 was exactly the value that we got. That was 126.87, okay, plus k 360 or 360k. All right, so those are our two solutions in this case for this particular case, and we know that k is always an element of integers. All right, so please always just keep in mind, just omit the negative so that it gives you that reference angle in the first quadrant, and then you can obviously work with whatever quadrant that you had. All right, now I want us to take the very last one, okay? All right, so we are looking at the last one. Okay, so in terms of, finding our reference angles, and in this case, we've got the 10. Okay, so we said we first need to isolate our trig ratios. So what I'm going to do is just simply say this is going to be 2. The 10 of x minus 10 is equal to minus or negative 3. And of course, divide both sides by 2, so that I'm just left with the trig ratio on its own. That's x minus 10. So that's 10 of x minus 10 is negative 3 over 2. Now, we need to get our reference angle. And I said in order for us to get our reference angle, we can just take, so it means that x minus 10 is equal to the arctan of negative 3 over 2. Okay, so in fact, you know, for our reference angle, please don't put that negative there. Okay, remember we said we're going to just use that reference angle there. In fact, I quite like that. So that's going to be 3 over 2. So in this case, we've got, for our reference angle, we've got 56.31. Now, please, I want you to note again, I need to go and check where is a 10 negative. If I draw that cast diagram again, where is 10 negative? 10 would be negative in the second quadrant. Okay, I'm just going to mark it in red there. And 10 is going to be negative in the fourth quadrant. So I'm going to take my reference angle. Remember, I said when you take that reference angle, don't put that sign there. So I'm going to take my reference angle. So now we are getting to the solution part. Okay, so my first one would be in the second quadrant. So it means that x minus 10 is equal to 180 minus my reference angle, which is 56.31. But remember, for 10, we say plus k 180. Okay, so in this case, what would be my solution? X minus 10 is equal to, okay, let's say 180 minus 56.31, and that gives me 123.69. Okay, this is plus k 180 or 180k, right? And of course, to get the value of x, all I need to do is just transpose that 10 to that other side. It becomes positive, so x would be equal to 133.69 plus k 180. And of course, we did say that it's also in the fourth quadrant. Okay, so again, x would be equal to our reference angle. Remember, it's 56.31. So x would be 360 minus 56.31. So that's the one in the fourth quadrant, 56.31. Okay, sorry, x minus 10 rather, not just x. So that's x minus 10. Okay, please don't forget that. Okay, so this is plus k 180. Okay, and this is going to be 360 minus 56.31. Okay, and what we get there is 303.69. Okay, plus k 180. You'll see that if you had just chosen, if you had just chosen that other angle and just keep adding 180, you would actually get that angle there. But that's another story for another day. So that's x. Now, if we want to get the value of x, going to add 10 to the other side. And so this would become 313.69. That's in the third, or rather in the fourth quadrant, where 10 is also negative. Okay, right. I just want to leave our lesson right there. I hope that I've been able to make that a little bit easier. Oh yeah, actually, before I forget, maybe let me give you one that you will try to do on your own. It's always important for us to do that. Let me just try and give you one that you're going to do. Okay, so let's say you are going to take the sine of x. It's equal to minus, okay, 2 over 3. Right, please find me the solutions there. All right, and please just post them or put them in the comment section. All right, otherwise I want to leave a lesson there. Please just make sure that you subscribe if you haven't. Okay, and obviously for those of you who need assistance, you can always get in contact with us. Otherwise, I'll see you guys next time. Sharp, sharp.